Okay, here we are with lesson 3, continuing our talk about percents. And this is comparing quantities with percents. So in this lesson we compare two quantities using a percent. We will build on their understanding of the relationship between the part, the whole, and the percent. It is important for us to understand that the part in a percent problem may be greater than the whole, especially in problems that compare two disjoint or separate quantities. For example, a quantity of dogs versus a quantity of cats. Now you might think, well, those are both pets, but ask any cat or dog lover and they will tell you that they are totally different quantities. For this reason, the formula part equals percent times the whole is going to be changed to quantity is equal to the percent times the whole from this point forward. This wording will work for problems that compare a part to a whole and in problems comparing one quantity to another. We continue to relate the algebraic model to visual and arithmetic models and come to understand that an algebraic model will always work for any numbers and is often more efficient than constructing a visual model. We are prompted to consider when a percent is greater than a quantity, as well as times that a percent is less than a quantity, as a bridge to concepts related to percent increase and decrease, which we will talk about in lesson 4. All right, so go ahead on your lesson worksheet. We have the opening exercise. Since many of these problems in this lesson represent percents greater than 100, these exercises will review different models that represent percents greater than 100. So go ahead and start the opening exercise. You're going to complete the opening exercise and continue the video to check your answers. Okay, you should be done with the opening exercise, so let's see what you got. So if each 10 by 10 unit square represents one whole, then what percent is represented by the shaded region? You should have said 125%. So in the model above, 25% represents a quantity of 10 students. So how many students does the shaded region represent? Well, if 25% represents 10 students, then 1% represents 10 over 25, or 2/5 of a student. The shaded region covers 125 square units, or 125%. So since 2/5 times 125 equals 50, then the shaded region represents 50 students. This isn't the only way you could have explained this. You could have used the fact that if it's 125% and 25% represents 10 students, well then you could just multiply that by 5. 5 times 25 is 125, and 5 times 10 is 50, and you could have gotten the answer that way. And that is what is being said right here. You may also recognize that 125% contains exactly 5 regions of 25. In this case, you would simply multiply 10 times 5 to get 50 to show that the shaded region represents 50 students. All right, let's take a look at example 1 on your lesson worksheet. The members of a club are making friendship bracelets to sell to raise money. Anna and Emily made 54 bracelets over the weekend. They need to produce 300 bracelets by the end of the week. What percent of the bracelets were they able to produce over the weekend? So what quantity represents the whole, and how do you know? The total number of bracelets is the whole because the number of bracelets that Anna and Emily produced is being compared to it. Again, when we talk about percent problems, we always want to start off by identifying what is the whole, what is the percent, and what is the quantity that we're looking for. So let's start with a visual. So if we have 300 bracelets, that's our whole. That is also equal to 100%. And then they made 54 bracelets. So in our percent model, what is that percent? 54 is what percent of 300? So 300 represents 100% of the bracelets. And 54 out of 300, if we turn it into a power of 10, which we can reduce this to. 18 goes into 54 3 times, and 100 goes into 300 3 times, so we can reduce by a factor of 3. And since we have this type of fraction, we can convert it to a decimal, which is 18 hundredths, or 18 hundredths, the shortcut for anything over 100, is we drop the fraction and call it a percent. So this would be 18 over 100 is 18%, or per 100. So 54 bracelets represents 18% of the whole. Anna and Emily were able to produce 18% of the total number of bracelets over the weekend. Next, let's solve the problem using the percent formula. Compare the steps used to solve the equation to the arithmetic steps previously used with the tape diagram. So again, we want quantity is equal to the percent times the whole. So we're going to let P represent the unknown percent because we don't know what that is. So 54 is going to be equal to percent times 300. Remember, 54 is the quantity, P is the percent, and 300 is the whole. So in order to isolate P, if we're multiplying by 300, then we would multiply by the reciprocal, or if you want to think of it as dividing by 300, it's the same thing. So 1/300th times 54 and 1/300th times 300 leaves us with 54 over 300 equals 1p. Again, we can reduce this to 18 over 100, and since we have 1p, we can just drop the 1. And back to the same thing as last time, 18 over 100 is 18 hundredths, or 18%. So the same thing, 18% of the total bracelets. So what similarities do you observe between the arithmetic method and the algebraic method? Well, in both cases, we divided the part 54 by the whole quantity 300 to get the quotient of 18 hundredths. So let's look at part B. Anna produced 32 of the 54 bracelets produced by Emily and Anna over the weekend. Write the number of bracelets that Emily produced as a percent of those that Anna produced. So, what is the whole quantity and how do you know? Well, the whole quantity is the number of bracelets that Anna produced because the problem asks us to compare the number of bracelets that Emily produced to the number that Anna produced. So Emily will be the part and Anna will be the whole. So how does the context of part B differ from the context in part A? Well, the whole quantity is not the same. In part A, the whole quantity was the total number of bracelets to be produced, which was 300. And in part B, the whole number quantity was the number of bracelets that Anna produced over the weekend. In part A, the number of bracelets that Anna and Emily produced was part of the whole quantity of bracelets, and in part B, the number of bracelets that Emily produced was not part of the whole quantity. The quantities being compared are separate quantities. So why are we able to compare one of these quantities to the other? Well, because the quantities are measured using the same unit, which is the number of bracelets. So let's solve part B using both the arithmetic method and the algebraic method. So here's the arithmetic method. 32 is the whole, or 100% of the bracelets. And we're comparing that to the part, which is 22, or the quantity. Again, 22 over 32 is 6,875 ten-thousandths. If we take that and multiply it by 100%, which is what we want to convert this to 100%, then that means we would have 68 and 75 hundredths percent. All right, let's take a look at the algebraic method. we use the formula quantity is equal to the percent times the whole. So P is going to represent the unknown percent, which means 22 is the quantity, P is the percent, and 32 is the whole. Again, to isolate P, we multiply by the reciprocal of 32, which is 1/32, and we end up with the same thing, as you can see. 22 30-seconds, 22 30-seconds. And when we turn that into a decimal, we get the same thing, 6,875 10,000ths. And we can turn that into a percent, just like we did here, and we end up with 68 75/100%. So 22 bracelets are 68 75/100% of the number of bracelets that Anna produced. Remember, Anna produced 32 bracelets and Emily produced 22 bracelets. Therefore, she produced 68 75/100% of the number of bracelets that Anna produced. So how does each method compare? In each case, we divided the part by the whole quantity and then converted the quotient to a percent. Do you prefer one method over another, and why? All right, let's solve part C using the arithmetic and algebraic method. Write the number of bracelets that Anna produced as a percent of those that Emily produced. So what is the whole quantity now, and how do you know? Now the whole quantity is the number of bracelets that Emily produced over the weekend, because the problem asks us to compare the number of bracelets that Anna produced to the number of bracelets that Emily produced. So how do you think this will affect the percent, and why? Well, the percent should be greater than 100% because the part, Anna's 32 bracelets, is greater than the whole, Emily's 22 bracelets. So let's do the arithmetic method. Again, 22 is the whole, or 100% of the bracelets. So the part is 32. And so we put the part over the whole, which is 32 over 22, which can be reduced to 16/11. Now we need to convert that into percent. So taking 16/11 times 100%, we get 1600 over 11%, because 16 times 100 is 1600. Now we're going to convert that back into a mixed number. 11 goes into 1600 145 times, with 5 left over, so it's 145 5/11%. And you can leave it like this. You do not need to, since it's a repeating decimal, we want to make sure we have an exact answer, so we're going to keep this in fraction form. All right, let's compare that to the algebraic method. Again, quantity is equal to percent times whole. The quantity, or P, first we got to let P represent the unknown percent. And the quantity is 32, and 22 is the whole, and P is the unknown percent. So clearing or isolating P, we multiply by the reciprocal of 22, which is 1/22, and multiplying 1/22 times 32 gives us 32 over 22, the same thing we have over here. So reducing that down to 16/11, which gives us 1 5/11 as our percent. So, but we're not in a percent yet. This is just a percent without the percent sign. So what is 1 5/11 as a percent? Well, what we have to do is multiply that by 100%, and that is going to equal 145 5/11%. Now you might be looking at this going, how did we get from this part to this part? And I'll go ahead and show you on the next slide. So bear with me. So 32 bracelets are 145 5/11% of the number of bracelets that Emily produced. Anna produced 32 bracelets over the weekend, so Anna produced 145 and 5/11% of the number of bracelets that Emily produced. All right, so let's take a look at why 1 and 5/11, how did that become 145 and 5/11%? Why is it not 100 and 5/11%? So what happens here is we're going to use the multiplicative identity. Remember that 100% is the same as 1. So we're going to take our mixed number, 1 and 5/11, and multiply it by 1. Well, 100% is equal to 1, so we're going to substitute 100% with 1 and 5/11. Now, going back and using the definition of 1 and 5/11, it means 1 plus 5/11. And we're going to multiply that by 100%. So now, using the distributive property, we multiply 100% times 1 to get 100%, and 100% times 5/11. Now notice what happens. This becomes 100%, and 5/11 times 100% becomes 500 over 11. Well, now we find out how many 11s go into 500, and that is 45 times with 5 as a remainder. So 45 times 11 plus 5 is 500. Now we put this back together. 100% plus 45 and 5/11% is 145 and 5/11. So that is how we get from 1 and 5/11 to 145 and 5/11%. You definitely want to make sure you write this down as an example because you're going to need to use it as we continue these. All right, exercises 1 through 4 on your lesson worksheet. Use an equation for each problem and justify your solution with a visual or numeric model. Continue the video to check your answers. All right, you should be done with exercises 1 through 4. So again, compare your answers and work shown to what is here on the page. If you did it slightly different, that is okay as long as you are showing your work. But please make sure if you have any questions, highlight it, make a mark or something, and bring these questions to class. All right, let's wrap this up. So what formula can we use to relate the part, whole, and percent? Again, we're going to call it quantity is equal to percent times the whole. Why did the word part change to quantity in the percent formula? When we compare two separate quantities, one quantity is not a part of the other. What are the advantages of using an algebraic representation to solve percent problems? It can be a quicker way to solve the problem. Sometimes the numbers do not divide evenly, which makes the visual model more complex. Explain how to decide which quantity in a problem should represent the whole. You need to focus on identifying the quantity that we are finding a percent of. That quantity will be the whole in the equation or equal to 100% when you use a visual or arithmetic model. All right, we'll see you in class.